I run TownRock Energy. We're a 10-year-old geothermal energy consultancy and R&D company based in Edinburgh. 10 years ago, I finished a geology degree at University of St Andrews and saw there was no commercial entity trying to develop geothermal heat projects in Scotland. So set one up, and 10 years later, there's 13 of us on the team, and we're working on a plethora of different renewable heat projects that usually involve getting heat or cooling out of the ground. I think all agree, we haven't heard yet from Andrew, but I think we all agree that heat needs to be electrified, predominantly to address climate change, but more recently as a real energy security issue. And the benefit of using a heat pump, of course, is the efficiency by which you can convert electricity to heating or cooling. And then the benefit of using geothermal energy or ground source heat pump is that you have even less electrical requirement to get that necessary temperature. And you have a lot less volatility on the efficiency of your heat pump as it operates through the coolest portions of the year, because the ground is a stable temperature. Now, the deeper you go, the hotter it gets, but you have to find areas where there is a lot of water in the ground if you want a large-scale, sort of multi-megawatt geothermal heating system. So you need a qualified team of geoscientists to help with that. But one project that we are operating is the largest mine water geothermal system in the UK. For a private company based in Gateshead, there's 3.6 megawatts of installed heat pump capacity that heats some warehouses. And the source of heat is water within flooded coal mines that extend beneath Gateshead and Newcastle and Durham. Underneath Scotland, Scotland's central belt, there are vast flooded coal mines that haven't been used for more than a few tens of kilowatts for heating, but have the potential to provide sustainably and for the long term at least 10% of Scotland's heat demand. And if we reject some heat into the mines, that number can go up to 30% or greater. More recently, we've been working on town-scale heat networks, and usually we'll work for commercial or industrial decarbonization, but town-scale fifth-generation networks that each house will have its own heat pump, but they'll be interfacing with a central loop operating at, say, 15 to 25 degrees Celsius. And the benefit of having that centralized system is that whole town can actually remove itself from the energy grid, because it can have its own on-site renewable electricity generation. And because of the centralized network and the thermal stores integrated into that network, you can be charging that up when the wind is blowing or when the sun is shining. And even using the ground as a way to store that heat seasonally as well. So we're working with a number of communities to help them become energy independent. And this becomes very exciting for this community because they can essentially have their own mini energy company whereby all the money they spend on energy goes back into their own community, democratizing the energy system. One of our flagship projects is walking distance from here. It's called Body Heat. It's a renewable heating and cooling system using a ground source heat pump, 12 boreholes, and we do cooling for, it's an arts and events center that has a lot of big music events. And when you have several thousand people dancing to good music in a venue, they produce a huge amount of body heat, and the venue needs to be cooled down. So previously that was just being rejected out into the atmosphere via air conditioning units, but we've put in a system that captures that heat and stores it in the ground and charges up the ground as a large thermal battery, which we can then draw that heat back out when the venue needs to be heated before customers arrive, or heat up a next door building as well. So there's a lot that can be done with the ground, and really interested to talk about that and the big picture of green heat with my panelists today.